Okay, so we'll take the numericals on Euler's theory of column. So from booklet, problem number 2, page number 39. Problem number 2, page number 39. I'm going to read the statement. Determine the buckling load for the strut T section. Mention काय केलं? Strut. The theory of column and theory of strut is same because both the members subjected to compression only. त्यामुळे column येईल किंवा काय येईल बाळांनो? Strut. Strut is also column. So determine the buckling for a strut of T section. Strut of T section whose dimensions are given. The dimensions are the flange width being 100. The flange width is 100. Overall depth 80. Overall depth it is 80. Both flanges and stem 10 mm thick, means flange and stem both are 10 mm thick. The strut is 3 meters long, so the length of this column is 3 meters and hinged at both the ends. Condition दिले, hinged at both ends. किती नंबरची कंडिशन आहे सांगा? This condition is first. So what is the Euler's formula? F is equal to pi square EI divided by L square. So this is the formula. Okay. Now take modulus of elasticity. Take modulus of elasticity 200 giga Newton per meter square. 200 giga Newton per meter square. I'll convert this first. 200 Newton per meter square means Pascal. So this is gigapascal. But Newton per mm square is megapascal. So I'll write here mega. मी गिगा मधनं मेगाला बाजूला काढले. गिगा means 10 raised to 9 and mega means 10 raised to 6. So into 10 raised to 3. So 10 raised to 3 into 10 raised to 6 is nothing but giga. समझले? So this is 2 into 10 raised to 5 Newton per mm square. 2 into 10 raised to 5 Newton per mm square. ओके, हे कन्वर्जन येत नसलं तर बाळांनो बघून घ्या, हे खूप सोपं आहे. काय गिगा 10 raised to 9 होता, मेगाला बाजूला काढलं, 10 raised to 3 राहिला. मेगा पास्कल इज नथिंग बट न्यूटन पर mm स्क्वेअर. आता यातनं 10 raised to 2 पर बाहेर काढा. सो 2 into 10 raised to 5. ओके, नाउ this is modulus of elasticity. Condition is given, hinged at both ends. So in this formula we know the length E given, pi constant, म्हणजे राहिला कोण? I. So only one thing is required to solve this numerical is I. I means moment of inertia. कसं काढायचं तुम्ही सगळे एक्सपर्ट आहे, बरोबर आहे? So to determine moment of inertia, first determine CG. So CG of T section कसं काढणार? Y bar. Y bar is equal to summation AY divided by summation A. Now here we are going to split this one into two standard shapes, that is two rectangular shape, first, second. Now area of first 100 into 10 into y. Y means distance of the CG of first section from either top or bottom. We are going to consider from bottom. So 80 minus 5, 75. 80 minus 5. 80 minus 5, 75. Okay, now second plus, for second section height is 70. 70 into width 10. This is the area. Now CG of this section from bottom 70 half 35. divide by summation of area 100 into 10 plus 70 into 10. If you solve, you will get centroid from bottom 58.5 mm. So from bottom, the centroid is lying at 58.5 distance. So this is your neutral axis, that is x axis at distance 58.5 mm. And if you calculate from top, then 80 minus this 21.5 mm. फक्त y bar का calculate केला because this section is symmetric about y axis. त्यामुळे त्याचा x कुठे आहे सेंटरला. So this is your CG. I'll mention this as G. Okay. Now after getting CG, the next step is moment of inertia. But here will require moment of inertia which is minimum. So we'll have to calculate Ix also and Iyy also. पहिला Ix calculate करतो जो सगळ्यांना येतोय. So Ix moment of inertia Ix is equal to, लक्ष द्या, Ix for first section. First section कुठला आहे rectangle. So the formula is BD cube by 12, B 100, D 10 cube divided by 12 plus AH square, area of this first section 100 into 10 into H means distance between CG of this first section with neutral axis. This is your H. So 21.5 minus 5, 16.5 square, AH square. Now plus for this second one, B D cube 70 cube divided by 12 plus area 10 into 70 into. Now we'll require the distance between CG of second section and neutral axis. So I want this distance. This distance is 35. 58.5 minus 35. 23.5 square. AH square. Okay. Already आपण हे भरपूर वेळा सॉल्व केले. Okay. So calculate and tell me the answer of Ixx. mm raised to 4. (952.99 into 10 raised to 3 mm raised to 4. Okay, so this is your Ixx. Now we want I minimum. So here we'll have to calculate Iyy. लक्ष द्या बाळांनो, हे सगळ्यात महत्त्वाचं आहे. हे समजून घ्या, हे आधी भरपूर वेळेला सॉल्व केले इन बेंडिंग स्ट्रेसेस अँड शियर स्ट्रेसेस. नाउ विल डिटरमाइन Iyy इक्वल टू, इन Iyy काय करायचं बघा, अगोदरचा बी आत्ताचा डी, अगोदरचा बी आत्ताचा डी, अगोदरचा डी आत्ताचा बी. काय म्हटलं मी कळलं, बीच्या जागी डी, डीच्या जागी बी अँड हाईट आधी H1 H2 हाईट म्हणून मोजत होता. नाव यू हॅव टू मेजर फ्रॉम वाय ॲक्सिस. ओके, दिस इज द डिफरन्स. सी, सो फॉर फर्स्ट सेक्शन BD क्यूब B 10 इंटू D 100 क्यूब. बघा की बरोबर उलटे केले. डिवाइड बाय 12 प्लस AH स्क्वेअर. लक्ष द्या, फर्स्ट आय विल मार्क वाय ॲक्सिस. आधी एक्स ॲक्सिस मार्क केला होता ना, आता काय मार्क करतो वाय. सो दिस विल बी युअर वाय ॲक्सिस. वाय. नाव CG of this section is on y axis. So if you want to measure the distance from y, then it is 0. बघा की असं यायला पाहिजे ना काहीतरी. तो कुठं आलाय बरोबर, y वरच आलाय. So this distance is 0. So CG is lying on the y axis. So AH is 0. So AH square is 0. Now plus for second, BD cube by 12. Now this is B. B into D cube divided by 12 plus A square. Now again the CG of the second section is on y-axis. So H is 0. Calculate, you will get IYY. 839.16 into 10 raised to 3 mm raised to 4. Now, in this numerical, we will require I minimum, where the moment of inertia is minimum. On that side, this column is going to bend. So, we will require I minimum. So, I minimum is IYY. So, we will have to take I value 839.16 into 10 raised to 3 mm raised to 4. So, this is your I minimum. Now, after getting I minimum, you have to just put this value into formula for both ends hinged condition. For both ends hinged condition, what is the formula? F is equal to pi square EI divided by L square. So, I'll put the values. F is equal to pi square into E. E is 2 into 10 raised to 5. Pi square E into I. I means I minimum. 839.16 into 10 raised to 3 divided by pi square EI divided by L square. What is the length? 3 meter. So 3000 square. Ka sanga? We have taken all the values in mm. So put length in mm. So pi square EI divided by L square. Solve. You will get Euler's buckling load. So this 184.04 10 raised to 3 10 raised to 3 ला मी काय लिहिलं आहे किलो. सो 184.04 into 10 raised to 3 न्यूटन मीन्स 184 किलो न्यूटन. एवढा फोर्स जर इथं लावला इन द बीम देन इट विल बकल. समजलं तुम्हाला? सो दिस इज कॉल्ड ॲज युलर्स बकलिंग लोड. आता तुमच्या लक्षात आलं असेल हा प्रॉब्लेम तुम्हाला एकदम फालतू वाटला असेल. का फालतू वाटला सांगा? कारण तुम्हाला काय काढायला जमले? आय. पण तुम्हाला आता आयचं महत्त्व कळलं असेल. जर तुम्हाला आय येत नसेल तर आपण काही करू शकत नाही. राईट डाऊन.